Hi everybody, very good afternoon, and like I always say, Andariki Namaskaram, Ellarku Swagatam, and a very warm Vanakkam to Vedanta J English channel. This is me, your master teacher Nabamita Ma'am, and today we are here for the physical chemistry marathon, guys. And yes, there will also be PYQs, that is previous year questions, are also going to be solved in this session. So quickly go and call up your friends because this session is going to be outstanding, and this session we are going to complete 3 chapters that are going to come in your board's exam. Yes. How is your health? A little worse than yesterday, but I guess I will only rest after your board exam is over, guys. Hello, hi Amudan, hi Priya, hi Nada, hi Shinis, Manoj. Did I have my breakfast? No, not today either. Not today either. I will have food after the whole session is over, and yeah, like I said, I will only rest after your board exam is over. A lot of sacrifice from me as well. Why yesterday evening no class? Because I took a lot of class, Baba. I took class till 6 o'clock in the evening. Do you really think after 5 or 6 hours I can stand up more than this? No, dear. Come on, bacha. What is wrong with you? I'm not a robot. I'm also a human being. Yes. Hi, Krishna. Welcome to the session, bacha. Welcome to the session. Yes, I will. I will. All of these. What happened to me? I know something very gross, but can I just show you, like, the tissue paper, Vicks Vaporub, Dolo, or Saridon just before I entered the class. So, yeah, throat pain, a little bit of fever, running nose. This is what is happening with me. I know I normally don't skip my food, but I had to take care of the slides right in the morning, and yeah, so I skipped my food today also. And now that I'm starting from 12:30 till it will last till 4:35, so obviously I cannot have my lunch as well. I'll skip my lunch anyway. No worries, no worries. You don't have to worry about me. Seriously, you really don't have to worry about me. It's okay. I'm gonna be here. I do want to sacrifice for this just so that you guys can get better marks. You come back and let me know that yes, ma'am, this session helped you. Yes, ma'am, we were able to solve the question. That is more than enough for me. Okay, that's more than the food. It's the food for my soul. Shreyas sir will also help with you. Yes, in the physics exam. Yes, absolutely. What is my cat's name? Wow. I did have my medicine though. Yes, I did have my medicine. There are 3 cats that I have. That's Leo, Felix, and Choti. I have 3 cats. These are their names. Okay. All right, guys. Shall we start with the session then? Shall we start with the session then? I will go to the hospital after your exam, guys. After your exam. Right now, if I go, they will give me very high doses of medicine, and I will fall asleep. I will not be able to take classes. So yeah, not right now. Okay. Oh, your name is Krisha. I'm so sorry. I'm so sorry. So sorry. Chalo guys, let us start with the session. So in today's session, we are going to cover 3 chapters, that is solution, electrochemistry, and chemical kinetics. However, unlike yesterday, we do not have to go through exactly NCERT. But yes, it is suggested, it is advisable for you guys that after the session, please go and read your NCERT once. However, I am not going to go through the NCERT. I am not going to go line by line through NCERT because that is required only in inorganic chemistry and not here. Okay? Alright. So first, we will be starting with solutions chapter. Then we will go to then we will go to chemical kinetics. And then we will go to electrochemistry. And for each of this, one second, sorry guys. For each of this, okay? Each of this chapter, we will be solving PYQs, that is previous year question as well. And tomorrow, that is on Sunday, we will be doing 75 questions for 75 questions related to physical chemistry and inorganic chemistry for 75% criteria, everybody. Is that okay? So this is the plan, guys. This is the plan, and everybody, this is going to be your 0 to superhero session. So quickly go and call up your friends because we are not going to waste any more time and we're going to start. And guys, once I start today, I promise I'm not going to look at the chat box. If you have any doubt that I have just taught, rewind, watch it back. But if you have doubt related to something that I haven't taught you, that you can write it down in the comment section because that I can take. Okay? Alright, now everybody, are you all here with me? Are you all here with me? Do you have a pen and a paper? Because we are going to start right away, right now, everybody. Shall we start? Yes? Shall we start? How long this session? I have no idea. Like I said, I have no idea. Hoping to finish it by 5 p.m. Okay? Alright? Yes. Very good, Sigma. Very good. Well done. So chalo guys, let us start with our first chapter, that is solution. Now the question is, what are solutions? First of all, what are solutions, right? The first question that comes in our mind is, what are solutions? Now we know that solutions are basically, my dear students, what are solutions, guys? Anybody in the chat box that you want to let me know? Solutions are homogeneous mixture of two or more than two components, right? Solutions are homogeneous. I'm going to write this down and then send it to you so that you have the notes and you don't have to make exactly each and every point that I am telling you. Okay? Solutions are homogeneous mixtures of two or more than two components. Okay? Two or more than two components. Am I clear? This is your solution. Now, what do we mean by homogeneous mixture? When we say homogeneous mixture, my dear student, we mean to say that something that is uniformly distributed throughout the solution. Okay? Something that is uniformly distributed throughout the solution. Now, what does that mean? For example, everybody, let us say that I mix some sugar in water. Then what will happen? Every sip that you take, is it going to be like, too sweet, not so sweet, too sweet, not at all sweet? Is it going to be like that? Or every sip that you take, it tastes the same, isn't it? It tastes absolutely the same. Hence, that is called as a homogeneous mixture. But a heterogeneous mixture, everybody, that bhujia or that mixture that you eat, right? Can you guarantee that every time you put your hand inside in the packet to take some mixture out, can you guarantee that there will be 5 peanuts, there will be 5 raisins, there will be 5 those sticks of bhujia? Can you guarantee that? Not at all. Not at all. So that is a heterogeneous mixture because things are not uniformly distributed throughout. Yes. Alright. Now generally what we notice is that generally the solvent, everybody. Yes, in a solution you notice that this is the solvent, isn't it? The solvent is the component which is generally present in large quantity. Alright. Generally it is present in large quantity. However, not always the case. The key word here, my dear student, is generally. However, solute is a component that is generally present in smaller quantity. Alright, everybody. Now, a solution, it does not have to be always binary. A solution can, my dear students, it can be binary, it can be ternary, it can be quaternary as well. Alright, it can be binary. See, binary means just two things. That means sugar in water, that's a binary solution. Ternary will be sugar and salt in water. Quaternary will be lime juice and sugar and salt, basically lemonade that you do. Yeah, lemonade that you do. Exactly. So that will be called as a quaternary solution. Okay. Now, who decides the physical state of the solution? Is the solution going to be liquid? Is the solution going to be solid? Is the solution going to be gaseous state? Who is going to decide that, everybody? Who is going to decide that? Yes. Who is going to decide that? That will be decided by the solvent. Yes, the solvent is going to decide the physical state. Okay, the physical state of solution. The physical state of solution will be decided by the solvent. Very good, Harsh. Very good, Ram. Very good, Vandana. Very, very, very good. Okay. Voice is too low because I cannot shout. Sorry, bacha. Yes, please increase the volume in your phone. Okay. Alright, everybody. Now, guys, let us understand that. Do you think that types of solution, when we talk about solution, does it always have to be liquid and solid? Does it always have to be liquid and solid, guys? Not at all. That is wrong. There are gaseous solutions, there are liquid solution, and there are solid solution as well. So when do you have a gaseous solution? When there is solvent gas, solute is also gas, right? At that point of time, you're going to have a gaseous solution. Example would be mixture of oxygen, right here, mixture of oxygen and nitrogen gases in the atmosphere, right? Yes, when there is liquid and gas, that is the solute is liquid and the solvent is gas, at that time the example would be chloroform mixed with nitrogen gas. Solid present in gaseous, camphor in nitrogen gas. You know that camphor sublimes, isn't it? Camphor actually sublimes. That means that from solid state it directly goes into the gaseous state, and that gaseous phase it can also get inside nitrogen. It can also dissolve in nitrogen gas, hence that will be called as a solid in a gas solution. All right, everybody? Yes, guys, getting it? Okay, now moving on, you have a liquid solution. In liquid solution, when the solute is gas and the solvent is liquid, you get to see that oxygen dissolved in water. I mean, that is how the fishes, they breathe, isn't it? Yes, the fishes, they breathe inside water because of this oxygen that is dissolved in water, isn't it? If it is liquid that is present in liquid solvent, that is ethanol dissolved in water, haven't you seen many people, they drink alcohol? How do they drink? They take a little bit of alcohol and then they mix some water in it. What is it? Liquid in liquid, isn't it? Solid in liquid, everybody, we all know glucose dissolved in water, sugar dissolved in water, salt dissolved in water. These are all examples of solid in liquid. And finally, coming to solid solutions, guys, when gas is dissolved in solid, the example would be, everybody, solution of hydrogen in palladium. Okay, liquid dissolved in solid, everybody, as you all can see, amalgamation of mercury with sodium. Okay, yes, solid in solid solution would be copper dissolved in gold. All right, so these are the ones that are the examples of solutions. These are the examples of solutions or types of solution that you might want to know. It may come in your exam for 1 marks, everybody, although I suppose that NCERT is not going to, I mean CBSE is not going to be that easy, but I'm pretty sure that they might ask you, right? Now we come across something that is called as expressing concentration of solution. So how do we want to express? Okay, how do we want to express concentration of solution, my dear student? Yes, how do we express concentration of solutions, guys? Do you all know? Now in our younger days, right, when we were छोटू नन्ना मुन्ना राही हूँ देश का सिपाही हूँ, when you were छोटू, you have learned something called as concentrated solution and dilute solution, isn't it, everybody? Yes, Shiva, Shri, Hemant, guys, shh, shh. Stop telling me what to do. This is my job. I know what to do. Yes, I really know what to do. Rajan, I believe that you are a little, you are a little late to the class, bacha. Take a look. I have already told you. Yes, one chapter at a time, right? I cannot teach you solution, electrochemistry, chemical kinetics all together, right? I am doing that in this session. I'll complete it. First solution, then chemical kinetics, then electrochemistry. This is going to be the session plan. Okay, this is going to be the solution. This is going to be the session plan. Apart from that, again, see, I can't tell you the exact time, bacha. First I have to finish the solution chapter, right? Then I will take chemical kinetics. At the end we will do electrochemistry, but I'll do it. Okay, and yes, we will do numerical. Yes, we will do PYQC. All of that is written here. I'll do it. So shh and listen to the class. You don't pay attention, you're going to miss out on what I'm teaching right now. And then none of the concepts will be clear. You will only be thinking, ma'am, when are you going to do electrochemistry? Ma'am, why aren't you switching off the caption, ma'am? What will you do with caption? You can't understand what I'm telling you or what? Huh? You can't understand what I'm telling you. Ji Dinesh, do you not understand English? You do understand English, right? And am I talking to you only 3 chapters? Bro, you tell me, what is the syllabus? What is the syllabus of physical chemistry? Do you have any other chapters in physical chemistry for class 12 board? You tell me. You tell me. Huh? Do you have any other chapter? See, again. And here, last warning. I saw what you wrote. If you do this, you'll be blocked. Okay? Yes, you'll be blocked. Okay? So try and not do that. Yeah. Somebody is saying surface chemistry. Guys, surface chemistry is a part of your class 12 boards. Huh? Is surface chemistry a part of your class 12 boards? If it is, then I'll teach you. No worries. If it is, then I'll teach you. Surface chemistry is a part of your 12 boards. I'll take it then. Okay. Alright everybody. Now when we were chotu and we were young, we knew that we have heard about some words such as concentrated solution and dilute solution, and especially when teachers used to take us to the laboratory. Have you noticed that there used to be DIL, DIL HCl, DIL H2SO4? Because I remember that when I came back from the laboratory, the first time I went to laboratory, I did ask my science teacher that, sir, what is this DIL NaOH? What is this DIL HCl? And he told me that, actually that, yes, bacha, that is dilute and concentrated. Now tell me guys, we are talking about, science. We are talking about chemistry. Do you really think that such vague terms like dilute and concentrated, would it suffice? Would it be enough for us to understand that what is actually the quantity that is present in the solution? Would it be? No. It will not be possible for us to understand the actual quantity, the exact amount, right? We're talking about science. Now, dilute and concentrated, these are basically what? Comparative, relative terms. For example, I always give you this, example, everybody. Imagine that Sharma ji ka beta, right? Everybody says that Sharma ji's son, he is the topper, everybody, right? That's the usual joke or the meme that we know, right? Parents will also compare that, look at him, he has done so better. How come you did not get the marks? So imagine if there is only one student in the class and that's just you. Then are you going to call yourself the topper? It's just you. So for you to be the topper, for your parents to compare you with somebody else, it is relative. You need somebody else, right? Similarly with the concentrated and the dilute terms also. If something is dilute, then it is dilute in relative to something else. If something is concentrated, that means there is something else that is not so concentrated. You guys are getting the point? Are you guys getting the point? Exactly, everybody. So that means that just coming across dilute and concentrated would not help us, right? And that is when we needed certain quantitative concentration terms, everybody. What did we need? We needed some quantitative concentration terms. So let us write about those, okay? Let us talk about the quantitative concentration terms, and there are 5 or 6 of them, everybody. There are 5 or 6 of them. Quantitative concentration, let us talk about each one of them. First of all, you have mass percentage, everyone, okay? First of all, what do you have? You have mass percentage. Then what do you have? Then you have mass by volume percentage, everybody. Yes, what do you have? You have mass by volume percentage, okay? Thirdly, you have volume by volume percentage, or just volume percentage you can write, okay? You have volume percentage. Then what do you have? Then fourth one, you have strength, everybody. Yes, you have to write about strength. Then you have everyone ppm, that is parts per million. All right. Then what do you have, everybody? This side, let us talk about 6 here. Yes, 6. You have mole fraction, right? You have mole fraction, everybody, don't you? You have mole fraction, isn't it? Then we can write about molarity. Very good, very good, very good. Yes, you have molarity. Then you have molality. Yes, then you have 9. How do you write 9? Yeah, this is up. Then you have formality. Yes, then you have formality. And 10th one pe you also have normality. Okay, then you also have normality. Cool, everybody? Yes, so these are the concentration terms. So let us write the definition, not the definition, let us write the formula for each one of them, everybody. Cool. Sabse pehle, what do we write about? Let us talk about mass percentage, okay? Let us talk about mass percentage, everybody. And what is the formula of mass percentage? Mass of solute divided by total mass of solution multiplied with 100. Very good. Yes. What is it? What is the formula? The formula, everybody, is mass of solute divided by mass of solution multiplied with 100. This is your mass percentage. What is the symbol? The symbol, everybody, is W by W. Isn't it? Very good, everybody. Very good. Now, mass by volume percentage. What do we want to know? We want to know mass by volume percentage. How do you write mass by volume percentage, everybody? Mass by volume percentage will be mass of solute divided by volume of solution. Yes, divided by volume of solution in milliliter multiplied with 100, isn't it? And what is going to be the symbol? The symbol is going to be W by V, everybody. Correct? Very good. Thirdly, let us talk about volume percentage, everybody. And how do you write for volume percentage? You will write it as volume of solute, guys. Volume of solute divided by volume of solution in milliliter, and that multiplied with 100 will give you your volume percentage, everybody. Very good. Yes. Now let us talk about parts per million, everybody. Yes, parts per million. Right here, everyone. How do you write it? You write it as number of parts of solute. Yes, number of parts of solute divided by, everybody, total number of parts of all components. Parts of all components, sorry, spelling mistake. Components, yes, components of solution. Components of solution multiplied with 100. This, no. Multiplied with 10 to the power 6. Okay, multiplied with 10 to the power 6. This will give you parts per million, everybody. Isn't it? Yes, yes, yes. Now, let us talk about molarity, guys. What is molarity? Molarity is moles of solute. Yes, molarity is moles of solute divided by volume of solution in liter, or you can write dmq. Okay, that is your what? That is your molarity. Remember, molarity is dependent on temperature. Now we come across molality, everybody. And what is molality, guys? Molality is moles of solute. Yes, moles of solute divided by mass of solvent in kg, divided by mass of solvent in kg, divided by mass of solvent in kg. So this is going to be your molality, capital small letter m, and this is your capital M, that is molarity, everybody. Very good. Yes. Now we come across strength, everybody. Strength is our seventh term, and our seventh term strength, everybody, is mass of solute in grams divided by volume of solution in liter, or dmq. Okay, what is it? Mass of solute, right? Mass of solute in grams, divided by volume of solution in liter, or dmq. All right, everybody. Now, coming to the fact that I wrote there are 10 types of concentration term. In fact, there can be more also. However, in your NCERT, you do not have formality. Normality, I have already given it to you in the formula sheet that I had taken very recently, day before yesterday in the evening. I have taken a formula session for physical chemistry. Please go and check it out. There you will find all the formulas of these concentration terms. Okay, formality you do not have to know, it does not matter. Mole fraction, everybody knows how to do mole fraction. Mole fraction of one component you find, everyone. Yes, how do you find the mole fraction of one component? Basically it is written as a chi of A divided by chi A plus chi B, right? That is how you write for mole fraction, isn't it? This is your mole fraction, everybody. Yes, with this note, all the concentration terms are here completed, everybody. Now we want to talk about something that is called as solubility, guys. Now, what is solubility? Solubility, when we write solubility, everybody, we understand that solubility means the maximum amount that can be dissolved in a given amount of solvent. What is solubility, everybody? Solubility is the maximum amount, yes, it is the maximum amount that can be dissolved, okay, that can be dissolved in a given amount, okay, in a given amount of solvent, everybody. All right, that is your solubility. Now, do you think that the solubility, will it depend on something? Will the solubility depend on something? Obviously. Can somebody answer, everybody? Yes. Yes. Shishira, can you please tell me? Can you please tell me? Shishira, I have told you, I have taken care of that already. I have done a formula session of physical chemistry. Please go and check it out. I've already provided you with a PDF also in the Telegram channel. Join the Telegram channel. You will find it all of it. Okay? Yes, everybody. Do you think that solubility depend on something else? Will solubility depend on something, everybody? Come on, guys, let me know. Yes. Yes, very good. Sabarish, very good. Solubility, yes, it will depend on temperature. What else? What else will it depend on, guys? What else will it depend on? Very good. Mohnish, very good. Hemant, very good. Pranav, very good. Crazy Queen, very good. Yes, what else? What else? What else will it depend on? Very good. Come on, guys, let me know. What else will it depend on? Vapor, pressure. Pressure is the right word, because right now we are talking about very vague terms. So yes, pressure is the correct word. Pressure, very good. What else? What else? What else? The nature of the solute or the solvent, isn't it? Nature of solvent or solute. Somebody said polarity. Yes. So the broader term here would be nature of solvent or solutes nature. Very good, everybody. That is the way to interact in the class. Well done. Yes, yes, absolutely. So these are the three factors on which solubility depend on, right? Solubility depends on these three, yes, these three factors. Very good. Okay. All right, everybody. This is clear, guys. Is this clear? Well done, well done, well done. Okay. Now, bachus, let us talk about solubility of solid in a liquid. Okay. Let us talk about, yeah, concentration also. There are a lot of things, but these three are the major factors on which solubility depend on. Okay. All right. Very good. Now, solubility of a solid in a liquid. So we see that when a solid solute is added to the solvent, right? So some of the solute, it dissolves, right? And what happens? Concentration of the solute increases in the solution. Am I right, everybody? Am I right, everybody? Is this clear? Is this clear? So when you have, let's say you have a little bit of salt. If you add the salt in water, then what will happen, guys? If you add the salt in the water, then the concentration of the salt will increase in the solution when some of it gets dissolved, isn't it? Some of it gets dissolved. And this process, when you are increasing the concentration of salt in the solution, by adding a little bit of salt again, by adding a little bit of solute again and again, this process is called as dissolution. What is it? This process is called as a dissolution, everybody. So let me write that down here. Okay, what did I say? I said that when a solid solute, okay, when a solid solute is added to the solvent, okay, when a solid solute is added to the solvent, what happens? Some solute dissolves, right? Some solute dissolves and its concentration increases in the solution. Yes, and the concentration increases in the solution. All right, this process is known as dissolution. Now, obviously, solubility, like I have told you, that it does depend on temperature. So the question that comes into your mind is, ma'am, how does temperature affect solubility, everybody? Now we know that in general, if it is in a nearly, okay, before we get into that, everyone, do you understand the difference between unsaturated, saturated or supersaturated solution, everybody? Yes. Do you understand the difference between unsaturated, saturated and supersaturated? So here we have a story time, everybody. Yes, let us have a look at story time, everybody. So imagine, not imagine, you all know that I really love biryani, isn't it? Because that's why I keep telling you that keep writing easy peasy biryani tasty, easy peasy biryani tasty, EPBT, right? I keep telling you to do that. Exactly. Why do I do that? Why do I tell you to write that? Because I really love biryani. So imagine that I'm very hungry, like after today's class, I'm gonna be very hungry, isn't it? I'm going to be absolutely hungry, everybody. So when I am that hungry, guys, what do you expect me to do? What do you expect me to do? I will be absolutely waiting with my plate that please bring the food, please bring the food, please bring the food, right? At that point of time, I haven't even stuffed my stomach. So what am I? Unsaturated. Yes, what am I? I'm unsaturated. After some time, let's say that now I have had 5 spoons of biryani, okay? After having 5 spoons of biryani, of course not, I can have 50 spoon of biryani. After some time, I'm a little full, okay? I'm a little full. Cool. Now, I'm a little full. At that point of time, let's call myself saturated. Now, of course, it is biryani. So, even though I am full, I am still not able to stop myself, and I feel like, oh my god, I really want to eat biryani, because who knows the next time I am going to get the biryani or not. So now I still feel like eating a little bit more, but actually I'm full till here. So what do I do now? I exercise a little bit, like okay, a little bit of digestion. After digestion I can eat a little bit more, so I am going to exercise a little bit, and also make sure that I wear a loose pajama so that my stomach can get inflated a little bit more so that I can eat more, right? So I eat a little bit more. When I eat a little bit more, at this point of time, I am completely unstable. I am full till here. And if somebody tells me that beta gulab jamun khaoge, ice cream khaoge, I might just puke it all over. I might just puke it all over, isn't it? Exactly the same analogy, if you bring it with solid and solution, yeah, if you bring it with solid and liquid and solution, you will actually see that this is the case here. So let's say that you have a glass of water and you add only 1 spoon of salt. When you add 1 spoon of salt, this water, it's like, bring it on, I can dissolve some more salt, bring it in, bring it in, bring it in. So at this point of time, the solution is what? The solution, everybody, is unsaturated. Now when you add 3 spoons of salt, this becomes saturated, because now the water is like, bas, that's it, don't add more salt, don't add more salt, I'm going to be unstable. But you do not listen. What do? You take the water, you heat it a little bit, and then you keep adding some more salt, and the water is like, I'm so sorry, stop it, I can't take more salt. At this point, the solution is super unstable, and it starts crystallizing, okay? It starts crystallizing, everybody. So this point is called as a super saturated solution. Now, did you see that during the solubility here, we did see effect on temperature? Solubility increased a little bit when you increased the temperature, right? Yes, when you increase the temperature, what happened? The solubility did increase for a while. Yes. So what am I saying? I'm writing here that in general, if in a nearly saturated solution, the dissolution process is endothermic. What is endothermic, guys? Endothermic is something that absorbs the heat. So you heated the solution. You heated the solution to make it take more solute. It is endothermic, obviously. The solubility should increase with rise in temperature, and if it is exothermic, the solubility should decrease, everybody. Do you understand this? Do you understand this? What happened here? Because the solution was endothermic. What do you mean by endothermic? Endothermic means that somebody is ready to absorb the heat. So because it is endothermic, what happens? The solubility increases. But if it was exothermic, that means if it was releasing heat, releasing more and more heat, now what will happen? The solubility will decrease, everybody. Yes, the solubility will decrease. Got it? Now the question is, what is effect of pressure? Pressure does not have any significant effect on solubility, guys. Yes, pressure is not a very prominent factor here. It is because solids and liquids, they are what? They are highly incompressible. We only know that it's the gases when we talk about pressure a lot more, isn't it? So when we are talking about solids and liquid, pressure is not very prominent. Pressure is not the main factor that we are looking at right here. Okay. All right, everybody. Great. Yes. Now, when we're talking about solubility of gas in a liquid, guys, at this point, check it out. Solubility of gases in liquid is greatly affected by pressure. Obviously, whenever we're talking about gases, we know that pressure will be a factor, right? Pressure will be a factor. And of course, the solution's temperature is also a factor here. The solubility of gases, it increases with increase in pressure. So when you increase the pressure, what happens? The solubility increases. And solubility of gases in liquids, it decreases with rise in temperature. When dissolved, the gas molecules, they are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved in the process. Forget about it. We will learn about this a little better in Henry's law. When we talk about Henry's law, we will be talking about this. But do you understand that why Coca-Cola is supposed to be had cold? Why don't we warm Coca-Cola and then drinking? Because then it will be just a liquid, it will just be a sugar syrup that you are trying to drink, but when it is cold, you get that fizz and it tastes amazing, like Coca-Cola, elixir of life. You feel like that, isn't it? Exactly, guys. So this is what it is about. Yes, this is what it is about. And then we will come to Henry's law. But till now, guys, what are the things that we have learned, everybody? Quickly, can we just talk about it? Quickly, can we revise what are the things that we have spoken about right now, everyone? Yes. What are the things that we have spoken about right now? Till now, we understood what is the definition of solution. What really is solution, we understood, and we know that solution can be binary, ternary, and quaternary, right? We also know, everybody, that it's the solvent that decides the physical state of the solution. Then we spoke about different types of solution, as in gas as a solute and gas solvent as a gas, solvent also as a gas. So we have spoken about gaseous solution, we have spoken about liquid solution, and we have spoken about solid solution as well, right? After that, we spoke about all the effect of concentration. After that, we spoke about the expressing concentration of solution. So there I have noted it down here, 10 ways to express the concentration of solution. However, we only took a look at 8 of them, because normality and formality is actually not there in your NCERT. However, I noted it down because this is important for your JEE mains as well. And your JEE mains second attempt is also coming up in April, everybody, isn't it? So you have mass percentage, mass by volume percentage, strength, you have ppm, that is parts per million, then you have mole fraction, molality, formality, and normality. Remind you, everybody, these are the only 2 ones that I have not spoken about. Rest everything I have written it down. The formula I have written it down. All right, everybody? Yes. Then after that, here I have jotted down all the formula, and remind you, everybody, the normality formula, I'm not writing it down in this session because this is strictly oriented towards NCERT. However, in the formula sheet that I have provided you with physical chemistry, that is in the Telegram channel, and in that you also have the conversions of normality to molarity, molarity to mole fraction to molarity, mole fraction to molality. All of that conversation also I have given it to you. Cool, everybody? Yes, so these are the formulas that we have taken a look at it. After that, we have spoken about solubility, guys. What is solubility? Solubility is the maximum amount that can be dissolved in a given amount of solvent. To understand it a little better, let's take it. The solubility is basically the amount of biryani that ma'am can eat. Okay, you can remember this in your exam hall. This is your trick. Will you all be able to do it? Yes. Does this trick make sense? Solubility is amount of biryani that ma'am can have. Right now, how much biryani can I have? I can probably have 1 kg of biryani easily. Right? I can probably have 1 kg of biryani easily, but this is basically your solubility. What are you going to write? You're going to write the maximum amount of biryani that ma'am can eat. Or you can change, you can modify the definition as maximum amount of solute that can be dissolved in a given amount of solvent. Is this easy peasy biryani tasty, everybody? Is this easy peasy biryani tasty? And solubility, it depends on three factors, that is temperature, pressure, nature of solvent or solute's nature. Now these are only the prime factors that we're talking about. There are obviously more factors, but this is what it is. Yes guys, is this clear? Is this clear, everybody? Is this clear, everyone? Yes, somebody was writing again and again that, ma'am, please repeat, please repeat, please repeat. Now that I'm repeating, I do not see his or her message. Where is that person? Who was that, Bachu? Who was that? Who was that who kept saying that? Where is that student? Now I'm repeating it, he's not there. Okay, alright. So, bacha, see, I am repeating also. Please understand that I'm doing everything that is in my hand. Be it repeating the concepts that I have taught you, be it taking care of each and every basics that you need in the exam hall. I am actually starting from the right basic, from the scratch basically, to make sure that you learn everything. Just please don't disturb the class here. Just please, like, one thing that I'm expecting from you is do not disturb the class. Because today I'm going to be a little strict. You have to understand that I'm not well. I'm taking a session and all of this effort is just for you. If you don't respect that, guys, it's going to be very difficult. So please, just make sure that you don't disturb the class. All of these things that you keep talking about, you know, that where you belong to, what are you eating, what are you not eating, can I get your Instagram handle, can I get your Snapchat handle? Guys, in 2 days you have your exam. I feel like I am the one who is putting in more efforts than you. Please don't do this, okay? Please don't do this. Focus up. This session is important for you, not for me. I have already made a life out of my life, you know. I have crossed all of that. I'm an adult. I get money, I pay my rent, I pay the bill and everything. I'm settled in my life. You are not. You still have to go there. Hai na? You still have to go there. So please focus up. Please show a little bit of seriousness. You really have a long way to go. Okay? Yes, you really have a long way to go. So please support. Okay? Alright, yes. So solubility is this. After solubility, I explained to you what is unsaturated, saturated and supersaturated solution. And how did I explain it to you? The same story of biryani. I love biryani and I cannot get rid of this story. I just love it, everybody, okay? I really love it. So yes, I'm gonna always talk about biryani. So biryani can make you understand unsaturated, saturated and supersaturated. Is there anybody who did not understand? Is there anybody who did not understand this? Yes, you did, right? After that, we spoke about effect of temperature, we spoke about effect of pressure, and then, now, at this point, we were done with solid in liquid solution, right? Now we want to talk about solubility of gas in liquid, guys. And the moment we talk about gas, obviously pressure and temperature both become very important. Now tell me something. Have you ever noticed that everybody, if you keep the Coca-Cola bottle outside the fridge, what happens? Outside the fridge, what happens? Then the next day, when you want to drink Coca-Cola, you open the bottle and there is no psst sound. There is no psst sound. That means the solubility of gas. The solubility of gas is, yes, it has decreased and the gas has gone away. The gas has gone out, the gas has escaped, and now what you have is just a sugary solution which does not taste like elixir of life, right? Does it? It does not. Exactly. And this is where, guys, we come across Henry's law. So this paragraph right here, read it again, everybody. Let's read it again, everyone. Yes. Let's read it again, everyone. Solubility of gases in liquids decrease with rise in temperature. This line, did you understand? This line, did you all understand? Or do I need to explain this? Because yesterday I saw that. You guys are so funny. Yesterday I saw that after I took the session, I was done with it. There were certain lines in NCERT which was very simple and there was no need to explain. So I read them through. and somebody commented, oh, you are just reading the NCERT, you are not explaining. So please tell me that did you understand this or should I explain this? Because later on I do not want you guys telling me that ma'am you are just reading the slide and you are not explaining. Yeah. So please tell me, did you understand that solubility of gases in liquid, it decreases with rise in temperature. This means that when you increase the temperature, solubility decreases. Solubility decreases. Okay? And when you dissolve the gas molecules, they are present in the liquid phase. And this process of dissolution, it can be considered very similar to condensation. You know what is condensation? Water vapor goes up and the water vapor gets converted to water, gets converted to liquid water. That is called as condensation, everyone. That is called as condensation, isn't it? That is called as condensation, everybody. So this process of, this process of dissolution, it can be considered very similar to condensation, and here heat is evolved in this process. During this dissolution, heat is evolved. That means exothermic process. So everybody, do you just notice? Some time back only we said that if it is an endothermic process, then what will happen? Solubility will increase. If it is an endothermic process, solubility will increase. But if heat is evolved, that is, if the system is exothermic, solubility will decrease. And do you see that? Do you see here in this line? See, it says, and the process of dissolution, it can be considered similar to condensation. That means heat is evolved in this process, and that's why we are saying that the solubility of gases decrease with increase in temperature. Yes? Do we understand this, guys? Do we understand this, everybody? Do we understand this, guys? Yes or no? Yes or no, everyone? Yes, we do. Very good. Yes. Yes, yes, yes. Okay. This color is different. No worries, no worries, no worries. Let me do one thing. Just a second. Can you see this better now? Can you see this better now? Yeah. So this is what is written here. Any which ways, I'll be giving you the PDF, so don't worry about it, okay? I will be giving you the PDF, so don't worry about it. Heat is evolved. Guys, when does evaporation happen? Evaporation absorbs heat to get to convert liquid water into water vapor, right? Evaporation is absorption of heat. It is an endothermic process. When it goes up, water vapor already has a lot of heat. Water vapor already has a lot of heat. This water vapor has to get converted to liquid water. What will it do? It will release some temperature to the surrounding water molecules and then get converted. So yes, it is an endothermic process. Yes, it is an endothermic process, Shavaris. Okay. Sishira, bacha, why don't you? Let's do one thing. Sishira, tell me. No, I'm not angry, by the way. Okay, I'm not angry. My tone might sound like this. Tell me something. When you go and watch, did you watch the movie Jailer, or did you watch any recent movie? Huh? Did you watch any Rajnikant's movie? What did you do? You went to the hall and you kept saying that Rajnikant sir, maro, beat him, Rajnikant sir, end the movie. Did you do this? Did you do this in the hall, movie hall? No, right? Then from the beginning of the session, when I was explaining you what is solution, you started with Le Chatelier's principle, and till now, after 20 minutes, you still haven't stopped about Le Chatelier's principle. What do you think? Can you wait? I'll come when the point comes. I have started the session. Just started the session. When the time comes, I'll explain it to you. Can you sit in the class quietly? I just started the session and I told you that water solution and you started with 𝐕𝐶𝐸 principle. Ma'am, 𝐕𝐶𝐸 principle. Ma'am, now she is asking, like in endothermic, is temperature always increasing? What is the use of 𝐕𝐶𝐸 principle? Bachu, why Bachu? Who told you that in this session, in solution chapter, 𝐕𝐶𝐸 principle is there? In this whole chapter, 𝐕𝐶𝐸 principle is not at all there. Then why are you constantly spamming? And in endothermic process, everybody, bacha. No. Sishira, we can go back, everybody. And we have evidences, okay? There are more than 200 students who are here. Who can tell me? So yes, everybody else, Harish, Krishna, Krisha, Ghost, Shayoni, please tell me, wasn't Shishira talking about 𝐕𝐶𝐸's principle since the beginning? Once or twice she spoke about molarity and mole fraction. After that, she kept talking about this, right? Why do you do that? You guys, seriously, this is a lol moment. This is a lol moment. Sham, don't do that, bacha. You don't be rude, okay? You don't have to be rude. No. She's also another student. So, Sishira, wait, bacha. Yes, if 𝐕𝐶𝐸's principle is there in the session, I'll tell you about it. If not, then please focus, okay? In endothermic process, heat is absorbed. Heat is absorbed, and if you talk about it in thermodynamic terms, that is in your class 11th, everybody. In class 11th, in thermodynamic, if you consider that there is a system, then that system, the temperature will increase because it is an endothermic. That means work is done on the system. You switch on the gas, you heat something, work is done on the system, okay? Alright, work is done on the system. So yes, temperature will increase when it comes to an endothermic process. In case of an exothermic process, heat is evolved, heat is given out by the system. So work done will be negative. Do you understand? Do you understand, everybody? Yes, okay? Alright guys, now moving on everybody, let us focus in Henry's law. Shall we, everybody? Are we all here? Are we all here? Yes. So the Henry's law, guys, when we're talking about Henry's law, we are basically talking about the solubility of a gas in a liquid. But here there are 2-3 things that we have to mention. What is it? The first one is this solubility of a gas in liquid that is happening. This is happening at constant temperature. How is it happening? It's happening at constant temperature. And this is directly proportional to the pressure of the gas that is present above the surface of liquid or solution. Yeah. Alright, everybody. So basically, if you look at this diagram, everyone, let's suppose that you have a normal pressure here, okay? Look at this diagram and try to understand. In the first diagram, yes, you have a cylindrical container. Yes, you have a cylindrical container. In this cylindrical container, everybody, you see there is a piston. But the piston right now is not working. You are not making the piston work at all, right? So here what is happening, you have liquid, and have you noticed that whenever you have a liquid, you must have also seen some amount of water droplets, and before the water droplets is there, that means that there are gas molecules. Correct, everybody? That means that there are gas molecules here, okay? So this liquid, which is at normal pressure, and here you have gas molecules. Now when you force the piston down, you are applying some force and you are pushing the piston down. What is happening? The gas molecules, now you are pushing them inside the liquid. So do you agree, everybody, that solubility of the gas will increase? Isn't this common sense, everyone? Isn't this common sense, everybody? That normally you had here gas molecules and you had the liquid molecules, right? The moment you force the piston, obviously the gas molecules are going to be pushed and they are getting inside the liquid. So as soon as you increase the pressure, tell me something, does it make sense that you have increased the solubility of gas, guys? Do you understand this? Do you understand this? Does it make sense that yes, you have increased the solubility? Yes, very, very, very good. Very, very, very good, everybody. Yes. So you have applied a force. And everybody, tell me something. What is the formula for force? Force is, everyone, what is force, guys? Force is equal to pressure divided by area. So that means if you increase the force, pressure also increases. So here you increased the force, you applied the force. So obviously, what is pressure? Pressure is intensity of force, isn't it? Pressure is intensity of force. You can actually never experience force. What you experience is pressure, isn't it? So here, the moment you have increased the force, pressure also increased and the solubility also increased, everybody. Coming back to Henry's law, make a note of what I'm telling you. I'm telling you that the solubility of a gas in liquid at constant temperature is directly proportional to the pressure of the gas. Shell pressure. Just a second, guys. Just a second. Just a second. Just have to connect it back. 1 second, 1 second. I'm back. Don't worry. I am here. Can you guys see now? Something is going on. Arey, wait, yeah. Continue. Everybody is lagging. What about now? What about now, guys? Give it 2 minutes. We will do it. Yeah, we'll do it. Don't worry. Now it's okay. Now is it fine?